Sure if this is this is better or not. I'm testing right now. Double check. I think the settings are correct, but I'm not sure. Sometimes Streamlabs goes crazy. All right. I think the problem is solved. I can hear it. It's fun when you start a live stream and then in the middle of the live stream you discover that your audio hasn't been working. Thank you very much, Nasser. This is very helpful. Thank you for letting me know. All right. Let's get started again. Well, we have a little bit more folks now who have joined us. So what I'm trying to do is I'm trying to prepare for a public speaking event on Wednesday. And I thought, since, I'm already doing this work, why not live stream it? I can share with you a little bit my thought process on how I design material and what are the things that go into the, behind the scenes, so that also you get the chance maybe to even participate on Wednesday and see how the delivery happens, right? So you can see what's happening behind the scenes, and then you can see how I deliver this material. I thought it would be useful to share a little bit how I think about things and how I try to, come up with the content that I share with you. And this is not just strictly for public speaking events. I follow the same process also for the other types of content that I create, even for live streams. Thank you very much, everyone, for subscribing, and for whoever is following both on YouTube and Twitch. I hope the audio is clear now. I definitely double checked it right now. It should be fine. And if you can give me a signal, also that would be really awesome, that you can hear me just fine. And what I was telling everybody is the event is called DevOps Day, and it's organized by We Are Developers. You can sign up for free. It's a pretty cool event to join. There are a lot of other really cool speakers who are going to be delivering, interesting talks ever since the morning, CEST time. I'm going to be the second delivering this talk at noon. I'm going to be talking about Actions Runner Controller and how Kubernetes operators are created. We're going to talk a little bit about the architecture of Actions Runner Controller, how it works, and what it takes to develop it. We're going to talk a little bit about what it does as well. But mostly it's going to be talking about the inner workings of Arc, as well as understanding its architecture and how Kubernetes operators work in general. It's a niche topic. It's a very focused topic on Kubernetes, and it's an advanced Kubernetes area. Not everybody is going to get the chance, not necessarily get the chance, but not everybody is going to have the need to actually build a Kubernetes operator at any point. But if the time arises for it, this knowledge is definitely helpful. Other speakers are talking about interesting things. I see something here about PaaS alternatives, accelerating authentication, talking about passwordless, which is cool. Passkeys are the new craze right now. And then, there's a talk about GitHub Actions, which is really awesome. Fantastic. All right. Let's see. So what I was trying to do here is, as I mentioned, I always start with building mind maps. All right, now I can hear that my voice is duplicated. Let me check. Let's see. So what I was trying to do here is, as I mentioned, I always start with building mind maps. Sorry about these issues. Usually the setup works fine, but sometimes you never know. All right. Checking very quickly. I don't think my voice is duplicated. I think what's happening is it's a bit loud, so it might be breaking. Let me reduce it a little bit. Maybe this is better. I'm not sure. Let me know. Give me a signal. I would be happy to keep on fixing this if it's not really working for you. All right, awesome. Let's move on. I'm gonna keep an eye on the chat so I can see what's happening. And let me know also if the text is clear or you need me to zoom in, zoom out, whatever you need. I'm also happy to accommodate. All right, so the event is gonna be on Wednesday. It's 12 p.m. It's for 45 minutes, and the audience is gonna be either DevOps or software engineers. Now, what are the objectives? That's what I start with, and also maybe let's talk about segments, because I also like to structure my talk in terms of segments. And more importantly, what I mean by segments is what's going to happen in the first 10 minutes, the next 10 minutes, so on and so forth, depending on how many segments I want to split my talk. And also references, because sometimes I reference other stuff, and it's important also to have a list of those. So let's see, DevOps, objectives. Some of the objectives that I would like to have are going to be around making sure, or first of all, help my audience or whoever is attending develop an understanding of Kubernetes operators. But this is a bit broad, so maybe we can refine it a little bit further. Understand the controller manager pattern, right? Maybe even, like this. Understand control loops. That's number one. I think that's important. That's as a concept to understand. And then understanding the controller manager pattern, understand custom resource definitions. These are important. And then one of the second objectives is develop an understanding of actions runner controller architecture. So once we cover the fundamentals of Kubernetes operators, maybe we can just again then dive into actions runner controllers architecture. And then here there are many elements to this architecture that we need to dive deeper into. Okay, just checking why my audio might be having an echo. Apologies for the problems with voice. Let me check here. I'm sorry, Akram. I'm not able to hear it. Maybe if someone else could confirm if there's an echo in the audio or not, that would be great. Either on YouTube or Twitch, that would be awesome. Thank you very much for your help. But I just checked it and I'm not really sure that I cannot hear the audio, the echo, sorry. All right, cool. Let's move on. So we were talking about actions runner controller architecture, and there are multiple elements to it. And for the folks who don't know what I'm talking about, I'm referring to this project right here. And if you have used GitHub Actions at all, you would know that part of using GitHub Actions, you could also use either GitHub hosted runners, or you could host your own runners. And the runners are basically the compute, the virtual machines or the containers that are able to run your jobs, that can do the work, right? So whenever you have a workflow, you have multiple jobs in that workflow, you need some form of compute to be able to do the work for you. And if you have no clue what I'm talking about, this will be a good time to go to my YouTube channel and start watching my my course on GitHub Actions. There's a whole playlist over here. It starts from the very basics all the way to all of the advanced topics. This is a full, full-blown course for free. It's about, I don't know, 7-8 hours long, maybe a little bit more. And then at the end, also, I cover Actions Runner Controller in depth and what it is, but we don't talk about its architecture. We talk a little bit about what it does, what you can do with it, how to set it up, how to use it. But in the talk on Wednesday, I'm going to dive a little bit deeper into how it's designed, how we build it, how we, maintain it, so on and so forth. And that is the purpose of this session. So this is the repository where Actions Runner Controller is hosted, hosted as code where we develop it as well. This is the repository. Arc is supported by GitHub, yes, but to be very specific, the new modes of Arc are supported. So if you go to this discussion over here, you go to announcements, you can see here that I have created an announcement that details exactly what is supported and what isn't. So if you go to this one, number 2775, you will see that I have a section about maintenance and support. And you will know, you will see there's a listing. I listed here what is exactly supported by. Nice, I broke my light. You will see here exactly what is supported by GitHub and what isn't. So these are gonna be the things that we support, and these are gonna be the things that the community will support itself, that GitHub is not gonna be maintaining. The community is going to be responsible for making sure that these continue working if they so desire. So you can find also here where the releases happen, the documentation, and everything else that is relevant. All right, give me a second. I need to go fix my light. I'll be right back. All right, cool. I think light is back. It's not damaged. This is like the 4th time it falls. Maybe it's time to invest in a better tripod for it. Anyway, all right. So I hope I answered this this question about support. Let's move on to talk about the architecture. So what do I want people to understand about Arc's code base? The code base is not extremely complicated, but it needs some context before you can actually dive into it. And you also need to understand how controllers are written and how custom resources are defined. We probably need to start by talking a little bit about the APIs and the API definition, because in my opinion, everything starts from here. So let me put some notes on the side here. Let's put this here. Custom resource definitions, APIs. Just because here the types are defined, different resources we're going to be needing. So with Arc, the new modes at least, we have the auto-scaling listener resource. It's a custom resource, and this is the spec where we can define exactly the fields that you can configure and what are the different elements that you can specify for this particular resource. Maybe it's important also, before we talk about resources, not only understanding custom resource definitions, but how does Kubernetes provision resources based on CRDs, right? It's important because otherwise any conversation about APIs is going to be meaningless. Yeah, because once we define these specs over here, we're going to be using automatic code generators that are going to go and they're going to create pretty much all of the different types and everything else that the operator needs to be able to utilize these resources, and then we can reference them in the controller manager where their state can be maintained, where they can be provisioned, created, so on and so forth. You can see here we can specify minimum, maximum runners, so on and so forth. And we have other types also, like the auto-scaling runner set. We have the ephemeral runners. This is how the runners are created. They have also specific configuration elements. Ephemeral runner set, I'm going to talk about the distinction. We need to talk about each of the resources, what is the purpose of it. But maybe, again, like here, it's going to be tricky to talk about these custom resources if we don't understand the overall, you know, architecture. But I also have a great diagram that explains the overall architecture, which we can, which I can reference here. So let's put it here. Let's put it as an element before. See, this is why I love mind maps, because they're so fluid. And then if I miss an element, I want to add another element. I thought about something different. It's just easy to integrate, you know. So we need to discuss the high-level architecture of what's happening, because otherwise this conversation is going to be meaningless. And the architecture is actually described in the docs, GHA runner skill set, and you can see here there's this high-level diagram. And then I describe in this diagram step by step what is happening when we run a new workflow and how do we actually provision new runners. I think it would be great to reference this diagram and talk about it at the beginning. So let me put this link here. I think this needs to go before we discuss Kubernetes operators, the control loops. I don't know. No, actually, yeah, this will motivate the whole conversation. Because once we discuss how this works, there will be like people will have a mental model about what are we actually talking about. And then we can, from the externals, zoom into the internals of whatever is happening here. And you can see the custom resources over here. And then in the next step, I can dive into each one of them and dissect it and share also where they are managed, so on and so forth. Once we define the APIs, I think it would be good to also come here and talk about the controllers, because these controllers are the ones that are going to be managing the state and making sure that these resources are provisioned. So for example, if we go to the auto-scaling listener controller, you can see here the code. You can see the reconciliation loop. Let me remove this one for now. You can see the reconciliation loop over here. I'm not sure if the text is clear. I'll zoom in a little bit. You can see the reconciliation loop, and what happens is every time this loop is called, we do all sorts of checks to make sure to basically match the desired state, right? So with Kubernetes, it's all about creating a configuration that reflects what we want. And then all of these different controllers are responsible for making sure that Kubernetes is always matching that state that we want, the desired state. And this is what I meant by talking here about the control loop, as well as the controller manager pattern. This is going to be the critical conversation. And then we can take one example of these controllers and dive deep into it. Let me put it here. All right. Now, once we understand a little bit how these controllers work, from the controllers, we can jump into the other internal libraries that we developed. For example, we can talk about how metrics work. We can talk about the different helpers. We can talk about the GitHub Actions client that we use to communicate with the GitHub APIs, right? The client is a bit more complicated than it should be, to be honest, but it's also quite important because it exposes all the different methods that we need in order to talk to the back end, pretty much. And then once we do that, yeah, we can talk about the main application besides the controllers that is called the actions. Sorry, GitHub Runner Scale Set Listener. And the listener is the thing that is driving the whole scaling activity, which is the listener connects to our backend. It is the one that actually receives the messages. So it creates a long pole connection to the backend. It receives the messages whenever we have new workflow runs. And the listener actually is the one that decides whether we need to scale up or down, and based on that, the listener will patch the ephemeral runner set. Again, I'm diving too much into the details here in the description, but just again, trying to describe what are these elements. The listener will patch the ephemeral runner set, and based on that, the controller manager will actually decide whether to scale up and down. So let's talk about here. Let's discuss the GitHub Actions client, or briefly discuss. We don't need to go too much into the details here. And then dive deep into the auto-scaling listener client, because it's important to understand how this client works. And I think once people understand this whole thing and they understand this loop, basically, everything else will fall naturally into place, hopefully. And that's it. This is the bulk of the GitHub Actions Runner controller. Everything else is pretty much, boilerplate code or scripts or whatever to try to maintain it. It's nothing really fancy, just stuff that is relevant to the development of Arc. And yeah, happy to answer questions if anybody has any, but I know this is too much of a high level thing. I'm not gonna really discuss how we build it, how we package it, and how we publish it, just because that's an entire hour all by itself. I think it would be awesome if I'm able to just cover these topics at the level that helps others understand what's really going on. Yeah, let me add them actually, how we packaging and releasing of Arc. All right. I think I'm gonna have to skip this one again because it's not pretty complicated, maybe a little bit complicated, just because we also have to deal with legacy stuff. We are trying to publish assets across multiple organizations. The workflows are slightly convoluted, way more than what I would love for them to be. There's a lot of complication. I worked so hard to really clean up this entire mess. But I think we have now a little bit of a good separation. We also have good end-to-end tests that cover a lot of different scenarios. And also covering how to run Actions Runner Controller locally for development. Might be also a good topic for another deep dive, just because there's a lot of configuration to be done. But it would be great to cover these topics for posterity and for the success of this project. I think if people want to be contributors, it'll take them a little bit of time to understand how to get this whole setup configured properly. But also I'm gonna skip this one because I don't have a lot of time on Wednesday to really cover these. All right, brilliant. So this is the lovely. I forgot to save this. Nice. Okay, so let's save it now. This is the mind map. Let's develop it a little bit further. So discuss the high-level architecture, design, discuss the diagram and the steps for provisioning new runners. Great. I mean, I can do the whole presentation from here. I don't even need a deck. Because what I love about this tool is you have a pitch mode. And when you go into pitch mode, I'm not sure if you can see it right now, but I can just jump from one topic to another. No, you cannot see it. It's on the other screen. Let me just see if I can change this. No, I cannot switch the screens. Never mind. But the idea is I can do a presentation right from the mind map without necessarily having a slide deck, a PowerPoint. But I'm going to create a PowerPoint anyway. All right. Nicola, thank you very much for following on Twitch. That's great. All right, brilliant. Where are we? Discuss the diagram. Okay. I don't think there's much to be said over here. I mean, the discussion of the diagram needs to happen with a discuss a workflow run end to end. It's already described in the diagram. I can just walk through that. Understanding control loops. What are control loops? The fundamental pattern that drives everything Kubernetes. This is it, to be honest. Understand the controller manager pattern. I mean, control loops and these they sort of, they're interchangeable, so let's just put it here. And let me put this here. Translate the high level pattern discussion to Kubernetes specific. Oops, not here. And then we put this underneath it. And then if we want to understand actions runner controller, we need to understand the custom resource definitions, describe each resource. Great. Take one controller as an example and describe its inner workings. Mainly what I need to describe is the walk through the reconciliation loop and what happens in that reconciliation loop. And what I like and hate about the reconciliation loop is that in Kubernetes in general, you literally have to think about all the possible states that your resources could be in. And then every time you go through this reconciliation, you need to check all of these different states, and based on where you think you are in the state, you need to make changes. And that can become a little bit complicated to think about, and it can be complicated if you have a lot of different resources doing different things, because it's also these controller managers, they work sort of the reconciliation loops for different controllers or for different resources, they are out of sync. So you never know when you're gonna go into the loop of another resource, right? So they have to manage this entire shared state in a parallel, but not necessarily, you cannot really share state in between all of these different controllers. So they have to maintain a consistency of resources without sharing state at all. All right. Now, this is what makes it a little bit more complicated. So we need to discuss the GitHub Actions client. This is easy. And then the action autoscaling listener client. This is where we need to discuss the long polling. Oops. Discuss the session authentication and session management. Discuss the long polling, and then we need to discuss the message acknowledgement process. And then part of all of this, we need to discuss patching, ephemeral runner set to scale, or let's not do it like that. Let's say scaling up or down. And I think, honestly, this is just, this is already 45 minutes. At the very least, this is if I sprint in discussing these. And I have already specific code examples. So let me do that right now. Let me have references. Architecture diagram. Workflow end-to-end. Control loops. This is going to be something external. The fundamental pattern. High-level discussion to Kubernetes specific. And then... okay, CRDs. We need to jump to this one. Let me take the link for this. Oh, no, actually it's this one. And then take one controller as an example. Let me put in the folder. Sorry, not this one. This one. And you notice like we already have... Hi, Eli. Thanks for joining. You can see here that we have also tests for these controllers. Let me put this link here. I think it's better. And then we walk through the reconciliation loop. I can also describe these from the test, but I think the test will complicate things a little bit, especially if we never talked about it. If you don't understand the pattern also, it will complicate things. But it's possible to understand what's happening through the test, yes. So GitHub Actions, sorry, not this one, it's command. And then we have listener. This is the entry point. So let's put this over here. We call it listener. Okay, what I need also for this whole thing is a quick demo that I can show, but without necessarily running it myself live. One of the things I try to avoid a lot is to do live demos, just because it's too stressful. Like, unless it's something I really care about creating a wow effect, I would really avoid live demos. I would limit live demos for things I want to, have a high engagement for. But in this particular case, I think a live demo is an overkill, and it might waste my time and might not allow me to really go deep into all of these different elements that I want to talk about in the session. That's why let's put here a demo, and I need to have a task for this. Now segments, I think it's already discussed in this section. I'm gonna rename it to material. And then I need to time box everything now, right? Because I don't want to overshoot my time. So this is also part of the thought process. Okay, so for this one, I would really... okay, here I should not be spending more than 5 minutes, and that honestly should include the demo. Okay, and then understanding control loops. I think this can definitely be done anywhere between 2 to 3 minutes. And this is maybe 1 minute. And let's see, custom resource definition APIs. I need to go through this, so it's probably gonna take 5 minutes over here, and then 5 minutes for this one, maybe 3 minutes for this one, and then finally this one should be 5 minutes. So let's see, what are we in total? 5 plus 3, 8, 9, 9 plus 5, 14, 19, 22, 27 minutes in. Yeah, I think we are good. I can definitely spend more time talking about... Oh, I remembered one thing. I think it's important to talk about folder structure. Let's add it here. And this is definitely a 5-minute exercise, because otherwise nothing will make sense. And maybe even as part of the introduction, discuss the new modes versus legacy. It's important to understand the distinction between the two, otherwise people will be confused. Yeah, and I think this definitely puts us in the time frame for the session. See why I love mind maps? It's just so awesome to be able to structure a whole talk like this. And the next step for me is to put it all in a deck and also share my screen, and then I can walk through these steps. So what I need to do is, for the session, I either have the mind map open and I follow it, or I memorize it, and then when I'm delivering the talk, I go through this mind map in my head, because it's already in my head, right? I memorized it while working on it. And again, this might not necessarily work for everybody, but I'm a visual thinker, and this makes my work so much better and easier. All right, cool. What else do we need to do here? I already have a deck. I can start preparing some of the slides. See how nice it is? When we have a great design team, they already have templates for us, which we can use, and that honestly makes life so much easier. What is the event? It is the DevOps Day on October 4. It's hosted by We Are Developers. I don't know, can I drop a link in the chat? Let me see. Twitch. Yeah, here's the link. Here's the link in the Twitch chat, and let's drop one in the YouTube chat. Whoever wants to join, it's free. You can book a seat and join on Wednesday. Then you'll be able to see the delivery of this planning. And again, for whoever's joining us right now, I'm working on a plan for the talk I'm delivering on Wednesday. And this is, I'm sharing my thought process and how I generally do things. It's going to be at 12 p.m. CEST, and it's going to be virtual, so you can join. I'm not sure if it's going to be recorded or released later. I have no idea, to be honest. I can ask. But yes, this is the event. And all right, let's see. How many slides do I actually need? I don't like slides. If you ask me, if it's up to me, I would do a talk without slides. And also, my slides have nothing, barely any text in them, just because I feel Slides are the most boring way to deliver anything. It's just awful. It's not engaging. It could be engaging depending on who's really delivering this talk, but as soon as I see slides with like 7 bullet points and I don't know what else is going on, I immediately shut down. My brain just immediately goes off. So I love the slides that barely have any text, maybe even just each slide with one simple idea, and that's pretty much it. These are my favorite. All right, so let's follow this flow. Let's see. We're gonna start with a high-level architecture. I think this is a great fit because I can bring this diagram here and then throw it into my deck, and then what I can do is I can discuss it. So this would be a great way. Let's go with this one. Fantastic. Look at this. It fits right in. I don't have to do much. And I think what I can do is to simplify the process. I can zoom into each one of these events and I can talk about it separately. So I can have one slide per event. That means I'm going to have 11 slides. Not necessarily. Look what I'm talking about. Here's what I'm talking about. So I can do a duplication. And then what I can do here is animate. And then once I click on this, zoom in, and then after previous, okay, but where do you want to zoom in? You didn't ask me. Where are you zooming in? Play. No, that's not what I want. No, that's not what I'm looking for. I'm looking for a... You know what? This is all bullshit. Let's do it the old-fashioned way. Just actually zoom in here. You can just resize this one and we're done, honestly. Here we go. All right, so let's center this. Okay, and then since we are centered now, yeah, forgive me, I don't know the... Okay, cool, this is it. Yeah, so this is the focus here, and then I can just describe what's going on in this slide. You see, much better. And then we can duplicate this, and without zooming in much further, so 1, 2, 3, we can bring this to the center, and then we can duplicate it one more time, and then jump to the number 4, right? And then we can duplicate this, and then jump to number 5 and 6. There we go. And then number 7. Seven and 8. Let's put it in the middle over here. And then finally we wrap up with number 9 and 10, which is this. Now, to make it a little bit more interesting to watch, or a bit more concrete, gonna start here. We're gonna zoom in. So let's put a little bit of box, just so that we can direct the viewer's attention. Let's make it transparent. And since we're already using green, let's make it green. I don't need the animation, I need the formatting options, and maybe even line 4 pixels. Yeah, perfect, excellent. So 1, 3. Let's put it this way. Oh no, let's keep it this way. And then number 4. Number 5 and 6. I think these would go hand in hand. Now I'm thinking maybe another color would be better. Let me see. Yeah, definitely better. 4 catches more attention. All right, cool. I see a lot of people coming in and out. If you're confused, just ask in the chat. I would be more than happy to answer your questions. Let's see. Eli is asking, is it possible for a beginner to understand 5 years of dev experience without any DevOps experience? Maybe. Yeah, I'm not sure this talk is really is going to be interesting for you're not a beginner, obviously. Like, you're definitely mid-career. But what I'm trying to say is, if you don't necessarily know GitHub Actions a little bit before, this one is going to be a bit tricky, just because there's a lot of context to be acquired first, and a lot of this will not really make sense, and it's going to be a deep dive into a very niche area. So I would say, as I mentioned at the beginning of the stream, if you go to my YouTube channel, my recommendation would definitely be to start with the GitHub Actions full course. It's for free. It's all on YouTube. You can watch it. It was my debut in YouTube content creation, so don't judge too harshly, but it's a discourse, and a lot of people vouch for it. It's great. It's complete. You can understand everything from overview of GitHub Actions, what they are, understanding continuous integration, continuous deployment, infrastructure as code. You can even learn how to write and publish your own GitHub Actions using OpenID Connect, and there's also an introduction to Actions Runner Controller that covers this whole concept end to end. So if you fit the profile of Eli, for example, sorry if I'm not sure if I'm pronouncing your name correctly, Eli. But yeah, if you're a beginner in that area, this would be the perfect place to start, because I think this is not only an introduction to GitHub Actions, it's not even an introduction, it's also a deep dive. It's an introduction to a lot of different DevOps concepts that you can acquire and learn a lot from. All right, let's come back to the slides. So number 5, 6, happy to answer more questions. So feel free to drop them in the chat. I would love to answer them. And this is why I do live streams, because it's just much more fun this way, and I can really curate the content to fit your specific needs. All right, let's move on. Let's move this on here. All right. Let's have a look, shall we? So slideshow. Boom. Ah, lovely. So one, then we jump to this, and then this, and then this, and then this, and then this. Excellent. It looks brilliant. And then I can have in my speaker notes exactly each one of these steps, and I can talk about it easily. Fantastic. This is the workflow run end to end. Then I'm gonna have a slide just for the demo. Probably it's gonna be a small video sped up. Just because I need to record this. I will do it later. 5x, maybe 5x speed is fine, and then I can talk through the video. I can do a voiceover, and then this is the demo. Then we need to jump to understanding control loops. Now, how do we describe control loops? Let's see. There's obviously the broad definition, which is too theoretical and too rigorous, in my opinion, which I'm not gonna dive into. So if you go to Wikipedia and look up control loop, right? This is the formalism. So it's part of the control systems theory, and control systems are quite difficult. So if you ask any engineering student, they will tell you that the formalism of this can it's not easy. Let's put it this way. I personally have never taken a course on control systems. I would love to take a course on control systems, but I'm also a university dropout, so maybe in the future at some point in time I will actually dedicate some time to understand control theory, but for now, yeah, I don't have the time for it, unfortunately. Maybe if I retire at some point and I can dedicate myself to full research and satisfy my curiosity about all sorts of topics, maybe I can do a deep dive on a lot of these things, and maybe we can do some live streams on them. But for now, we just have to go with the motions a bit. And yeah, so you have to understand the basics, but I don't think a deep understanding of the theory and the formalism is necessary to understand what's going on. And there are a lot of different control systems that are in play, and I think what we want to talk about is a closed loop control system. Because if you see here, because it incorporates some form of feedback, and I think that definitely applies to our situation over here with Kubernetes, because the feedback is whether we sort of have a desired state, we try to apply it, and then if it doesn't get applied, we get back information about the state, and then based on that we can make a judgment call on what to do next. So the state machine is a bit more dynamic than, there's some feedback that can be done to change this jump from one state to another. And I know this can get complicated quite easily, but the main principle here is that where can I draw this? Where can I draw this? 1 second. Simple drawing whiteboard. Let's see. Oh yeah, this is what I've used in one of my previous videos. Let's delete this. What I'm trying to describe here is that the Kubernetes controller, we have a desired state. So we can say, for example, I want 5 pods to be created. Let's say, sorry for my terrible handwriting. And then what happens is that this is the desired state. This is what we want to get to. This is our target, right? And then we have something called the controller manager. Let's call it CM. And then the controller manager is running in an infinite loop, basically, right? You don't have control over like how much time, how the frequency of this loop, right? So just let's say it's a very fast loop. And then when you say you want 5 pods, an event is queued for this controller manager, right? So the controller manager knows that now my state has changed. Someone is asking me to make 5 pods available. And then the controller manager will go into the loop, right? So let's say here we jump into loop number 1. And in the loop number 1, we have something called a reconciliation function. And this is just a regular function, you know. In this function, there's like conditions to check what is our state for this one, what is our state for that one, what is the information we have available, are we authenticated, are we not, blah, 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 whatever you want here. Okay, and then based on these conditions, we need to come up with what we need to do next. So the next could be that our current state, we have 0 pods. And then the next state we need to move into is to create 5 pods, right? So this is going to be the first iteration of the reconciliation loop, okay? Then once we finish this, we tell Kubernetes, great, through the APIs, we need 5 pods. And then Kubernetes is going to go and it's going to try to create these 5 pods for us. So it's going to make an attempt to create the pods. So let's say it created 1, 2, 3, 4, right? It didn't create 5, it created 4. And by the time when these 4 have been created, we went again into the reconciliation loop, right? This is why it's a loop. So we went into it again. Right now, we go through the conditions and we check here. Instead of 0, we actually have 4 as opposed to 5, right? So what we need to do is we need to tell Kubernetes, either we can say, okay, let's wait a little bit more. Maybe they are still being provisioned. Or we can tell Kubernetes, hey, you didn't give me 5, you gave me 4. So please give me 5, okay? And then Kubernetes will make another attempt to create the pod. And in the next iteration over here, Kubernetes is going to tell my controller manager that, hey, I created your 5 pods. What do you want me to do next? And then the reconciliation loop is going to check and it's going to see that we have 5 out of 5 and that everything is in order. So it's not going to do anything. It's just going to skip and we are in a perfect world. Now, another thing that could happen is one of these pods could fail or it could get terminated or whatever. So again, from this state, we need to jump one more time into the reconciliation loop, which runs indefinitely, right? There is no termination point until maybe we delete this controller manager. And then it's going to run through all of the checks again and see what is my desired state. But in this case, the desired state is not going to be different. We're done. The initial condition is met. It's satisfied. We scrub it off. We don't have any new queued events from this side. There aren't any. So the desired state is to actually go back to 0. And that's why it's not going to complain that one of these pods is done or it's finished its work. What it's actually going to do is going to trigger a cleanup process. So it's going to actually clean up all of the traces of this particular pod. And that's it. We run this loop indefinitely and we continuously make sure that our desired state is met. So this is how it works in short. This is it's great going through this right now because now I'm thinking that I might need to actually create some diagrams for this and or create some drawings to explain this concept a little bit. But this is it in short, basically. And maybe what I need to do here is to yeah, all of these fit under what I just described. So maybe I need to also reference some of this material over here. Okay, let me put here a to-do. See, this is how I think about, again, material that I design. It's just, again, walking through it, debating it in my head, trying to create assets. Right, so I'm going to create diagrams and then let's add some markers over here that this is not started yet and this is not started. Why this is cool? Because I can filter by markers, so I can have a list of the stuff that is completed versus the stuff that has not been completed yet. All right, I think we're gonna come to an end of this stream soon because it's almost dinner time on my end. I also need to spend time creating this material. But I'm really happy where we are today. Here I don't really need to do much. I just jump to the GitHub repository and I describe things over there. Also here, same thing. Same thing for this one. Same thing for this. And same thing for this one. What I probably need to do for each one of these is to create permalinks with specific line references for each one, or take snapshots of each one of these and here it might be a good idea to reference the discussion. So let's grab a link for it. Generally available, plop, plop, plop. There we go. Excellent. Well, I'm actually very happy with the structure of this talk. I think it's going to be interesting, hopefully, and I think it's going to be of added value also, because people are going to come out understanding Kubernetes a little bit deeper, and also understanding Arc a little bit deeper, and maybe something that they could actually implement and use at work or for their fun projects or whatever. All right, love it. Brilliant, folks. I really appreciate whoever stuck with me while I blabbed through this 1 hour or something. I hope you learned a thing or two from it. If not, I hope you had fun. If not, I'm really sorry for wasting your time. I'm gonna definitely do more live streams like this that are a bit casual, less structured, and maybe share with you some of my ways of working. But also I'm gonna do more live streams where I code stuff, and I think I'm gonna really need to spend some time on finishing my rewriting Git from scratch series, because I think it's awesome. But unfortunately, I've been really occupied both with work and public speaking lately that I'm really not able to dedicate any time to develop it further. But hopefully, once I finish this series of public speaking engagements, I'm going to be able to dedicate more time to this. And one more announcement here is that I'm going to be speaking at GitHub Universe this year. And if you don't know, GitHub Universe is our biggest conference. It's really cool. And it's in San Francisco between November 8th and 9 this year. And I'm going to be there. I'm going to be talking about GitHub Copilot. And I'm going to be really excited to join everybody on stage. This is a great opportunity. So yeah, if you get the chance to grab your ticket, at the very least, try to grab your free virtual pass. Otherwise, if you're able to attend the conference in person, it will be really awesome to meet you in person at GitHub Universe this year. Yeah, I didn't want to announce it because I'm waiting for my talk to be in the catalog, but I'm going to share a little bit more about it. And you can see also we have a lot of amazing people who are going to be speaking as well. I've had Simon already make an appearance on my podcast. I really love Simon. He's so cool, and I'm really excited to meet him in person. We also have Thomas, the CEO of GitHub. We have a lot of awesome engineers and tech folks who are going to be presenting. There are plenty of really cool sessions at GitHub Universe, and yeah, there's a lot of content for everybody, I guess. All right, folks, this is awesome. Enjoy the rest of your weekend or start of your week, and I will catch you on the next live stream. Hopefully the next few ones are gonna be maybe scheduled, and yeah, I will see you then. Take care, everyone.